Yes. So, yeah. Hi, everyone. Great to see so many people. I did a talk now at DroidCon in London a few weeks ago on with the same topic. So I decided to reuse that one, and then I decided to rework it a little bit to have a focus that is more relevant for actually working with AOSP and not so much about the hardware itself, um, which was more about lessons learned over time for me. I decided to reuse this first like intro slide I have because it's such an amazing image that I got from ChatGPT. I really love the details of it. I want that keyboard, and I'm very curious what the knife is doing there. But I
And
basically fed in the title
also, I'd like
working
to
with
point out,
customer.
sorry, I'd
Yeah,
like to point out that those pairs of scissors, those scissors were not going to work. Those are non-functional
yeah,
scissors.
yeah, yeah. I don't know. I'm very so many things that I'm curious about. But it's great. I'm like yeah. You could look at this forever. But anyway, so the title was talk then was working with custom Android devices. And before I continue on, all my slides will be uploaded on SpeakerDeck. So speakerdeck.com/Erik Hellman. These slides are not there yet. They will be after this presentation. And yeah, so I usually don't list an agenda here, but since we have like an online here, I thought I would go, and it will be recorded. I thought I will like cover this one and explain what I'm going to talk about. I removed most of the details from my DroidCon talk where I like talk about experiences with different suppliers and OEMs and ODMs and stuff like that. So if you were interested in those parts, the DroidCon talk that I did will be online soon. I don't know if it's up already. Anyway, but let's focus on the things that are actually fun and interesting, or fun and interesting. And that's actually getting to work on a custom Android device where you have a custom version of custom device that you get from somewhere, and then you're gonna build apps or libraries or something for this one. Okay, let's get started. So the first thing you all know this one. Anyone worked with AOSP before? You know you have to do a repo init. The problem with this one is that you get a URL from the company that supplies you with the source code for that particular device. You rarely, when you're going to work with this professionally for a company, you have a custom device that is built on a custom SoC. So it might come from Qualcomm or NXP or Marvell or Broadcom, or I don't know, there are many. And they will have their own version of AOSP, which is a fork from Google, so often a few versions behind. So for instance, currently I'm working with Android 12.1. So they give a URL and they tell you to use this branch, and they might also tell you to provide the manifest parameter to repo init. And you tell you, yes, clone this one, do that, and then you can start building. And before you run this the first time, I say don't do it right away, because many people do miss to create a mirror. And the reason you want a mirror, because you probably don't have like a high-end build server for everyone in your team. Maybe you need to share one. Maybe the network to the company that supplies you with the source code is really bad because they're in China, so it's behind the Chinese firewall. So you want to create a mirror of that repo that they have. And that's why you do this -- mirror as well. Now that will kind of like create like a local copy that you can do on the same machine, or you can do a repo init with a URL to your own server. And you sync that mirror, and then you create a new workspace locally on the machine, and then you do another repo init now with a -- reference, so that you reference that path instead. And that way you can be multiple people using the same server and then just cloning a local mirror instead of everyone cloning the remote mirror from over the slow network. That's tip number one. Now, proprietary binaries. Proprietary binaries. That comes with any of these devices. If you're getting a Qualcomm device or if you're getting an NXP device, there are proprietary drivers that are not open source. You don't build them. You basically just download a zip file or tar file, then you extract it. This includes the Pixel devices. So if you're going to do a custom Pixel device build, it's documented on the source.android.com how to do it, and you probably have something similar for the hardware that you're going to be working with. You won't be able to complete the build unless you do this. So even if you get the source code for weird NXP device, you still need that weird zip file that they probably provide over a SharePoint share usually. After you signed a bunch of NDAs. So yes. Now, this was something that I discovered that was confusing for many people, and I was I was really surprised about it. It turns out that people in the industry have misunderstood what how the launch targets work. So you get the documentation saying, okay, you load the environment setup, and then you run launch, and you get a list of launch targets. So if you do this on the regular AOSP from Google, you get a long list here. And here you see Flame and Redfin. Redfin is a Pixel 5. You see user debug, and you see car user debug. But note here that you don't see all the variants. This launch menu, when you run the launch target without a parameter, it gives you the common launch targets. And then you can enter these here. So some partners that build AOSP or integration AOSP on custom devices, they think this is the complete list of launch targets. So they don't know that you can actually do engineering build and user build as well. So if you check in the Android products on the product that you're working on, it's going to have this line, these lines here in the bottom, saying which are the common launch targets that's going to be included when you run launch without parameters. Now, if you want to add engineering and user build here, then you just add those lines in here. So why is that important? Well, it turns out that some of these companies that does AOSP integration on hardware, they modify the existing variant, the existing user debug variant, because it doesn't show up when they run launch, so they think it's not supported anymore. And that's unfortunate. So they might just enable a bunch of stuff here in the user debug that comes from engineering build, and that kind of pours over. So it's very bad. So it might end up in the user build as well eventually. So when you come across a partner that does AOSP integration, and you're supposed to write the system apps, and they only provide the user debug, and they use the user debug as an engineering build as well, then you tell them this, that, just because it doesn't list it in the common launch targets doesn't know it doesn't exist there. All products have an engineering build and a user build and a user debug or variants. Important thing to remember. Now, I'm checking the chat here meanwhile. Yeah, providing dirty AOSP BSPs. Yes. Yeah, that might happen, that the builds are broken. So anyway, so if you add something like this, you add the engineering build here, and suddenly it will show up when you run the launch target. Now, this is usually not something you have to do much. Well, you might have to do it once because you get you need to define your own product, but usually it's very small. So adding a new device, you get the source code from the partner to, like, it comes from Qualcomm, or it comes from NXP, or it comes from one of these SoCs, and you need to basically inherit from that one for your own device. What you do is you create the directory in the AOSP, and then you edit the file Android products. And that one basically, in the very most simplest case, looks like this. And here we point to a local file there, say AOSP mydevice.mk. And well, you can provide common launch choices, but you don't have to. Now, in this AOSP mydevice.mk, you call these makefile scripts. You inherit a product. You probably want the core 64-bit. You probably want telephony if it's a telephony device. And there are a bunch of others here as well. Then you set up the product name, product device, brand, model, manufacturer, etc. And then you can inherit products. So in this case, I decided to do a custom Pixel 5 build. So I have my own device, but which will be built for Pixel 5, but inherits everything from the Redfin device Redfin here. There is also an inherit product if exists, which, well, it's obvious what that one does. So now you have your own product, and you can start building with that one instead. So you get your own launch target, and you can do all those things. The first thing you're probably gonna do when you're working with a custom Android device is gonna tweak the system properties. This is fairly well documented on source Android.com, but it's good to know about this. You have product system properties, and here you can just list this one. So this you include in the, well, this AOSP my device make file. So you can like disable the lock screen, you can configure it for low RAM, etc., etc. These are the system properties that you get when you run adb shell get prop. And RO in front of them means that they are read-only, but they're built in and they're read-only in the system. Which properties exist? Well, there's lots of them, and you can define your own, and you have to search through the Android open source project code base basically to find the ones you're looking for. It's a bit of detective work, I can tell you. Another very useful thing is resource overlays. This one is the second most common thing you're going to do on your custom projects. You have the device defined and everything. You add this line, and it basically just points to a folder where you're going to put overlays. And overlays are resources that are going to override the ones that are built into other parts of the AOSP. So here, for instance, for the Redfin, which is a Pixel 5, it defines this directory. You can find it there if you have AOSP checked out. And if we go into that one and we get three folders there: frameworks, packages, and vendor. Frameworks is the one that's interesting, which basically is like the system APIs and system resources, the base Android.R resources, basically. You can override the ones that are in there. And you can override package resources, like for other applications, and you can for other system applications, and you can override the base resources. There's also the possibility to override individual packages that comes default in AOSP. So, for instance, if you want to replace the app that's the default clock, for instance, you can do that in this way, or resources in the default clock. Not the app itself. You do that in another way. So how do you overlay resources? Well, for instance, if you check in framework-based core res, then you find a config XML, the one that is in the system AOSP, the one you shouldn't modify. You want to modify the values there. You want to override those. So you define your own config XML, which goes into the directory, which goes into the directory I just showed. And then you add the resources that you want to override and the values with them. And it's a regular Android resource XML file. So nothing strange there. So this is the second most common after the properties that you're probably going to do. And it's very helpful. Again, if you go into that, I can show you the XML file later, maybe if we have time. And there's so many to find there. Now, the most common thing when you work with a custom Android device, sorry, I can have some water. Yeah, so the most common thing you do is to add your own packages. And with packages, I mean apps, but it can also be libraries. The apps can be built built by AOSP, or it can be an APK that you import. So either you have developers in a different teams writing an app that's going to be imported into the AOSP build and part of the system image, or one of the priv apps. Or it may be a Java SDK library, or it may be a Java library that's going to be shared by multiple system apps, and so on and so on. All it can be native code, etc. But I'm going to show three things to do here: the importing and how you add a new app that's going to be built by AOSP, how you import an existing APK file, and then how to define a Java SDK library. I'm going to show that briefly. It's a little bit more complicated than I'm going to show, but at least you get a start there. So you do this by using the Zoom build system that Chris just mentioned before, and you can go and look at the reference for that one. It looks like this. And it's a very big HTML file that you can navigate around. And it's really hard to find this one if you're not used to it. There is a link on source.android.com, but I'm going to show the link next here. But also, as Chris mentioned, they are switching over to Bazel, which supposedly will be better eventually. Currently, it's a little bit flaky. Let's call it that. So this one will be relevant for the foreseeable future, I would say, the next 2 years at least. This is the link to this site that I just showed you here. So you will find that one in the slides and you can download it later. It's basically an HTML file where you can navigate and see all the possible properties and build statements that you can do with Zoom today in the latest version. So that's a very good documentation to keep track of. Now, how does it look? Let's say that we're going to add a new system app. It's going to be built by AOSP, so you're going to check in all the source code and everything. So what you need then is an android.bp. BP stands for blueprint, I think. Yeah, something like that. So what you have to do there is it contains an Android app statement, and then you have a name, and this is the name that you're gonna add then later into your product as well. So this is an important file string to keep track of. And then you just point out where is your resource directory, which SDK version do you want to use. Probably you're going to use current, which is the one that's going to be like associated with this product that you're building. Where is a source code? Is this a product specific one? Yes, it is. And then you can include the static libs that are part of AOSP. And you see here recycler view and lifecycle and arcs and collection, etc., Android material, etc. These are not Gradle dependencies, I believe, but these are actually those libraries that are part of AOSP as well, so that can be built there. Now, the other way is to import an APK, and this is the way I prefer. So you have a team that is used to do Android apps. You tell them to build a new home screen launcher for, let's say you're doing an Android TV device for someone. And they want their customized launcher. So the team that built a customized launcher, they're supposed to be building this one with Android Studio, sitting on their MacBooks. They are not going to know much about AOSP. And this is because this is probably going to be a very complicated app, but you're probably not going to find all the people doing that. You're probably not be able to provide them all with high-end build servers on their desktop. So all this is the reason why you want to do it this way. You want to build the app separately and then import it into. Therefore, there is this Android app import. Again, you just give it a name. You tell where the APK is, local, relative to this file, the Android BP. And then you tell it which certificate to provide. You can also tell it that it's pre-signed, etc., with an existing certificate. But here, for instance, I'm doing a system app. It's going to be deep system permissions, etc. It's going to have to be signed with a system with a platform certificate. And then I tell it here, certificate, well, use the one in the platform. So it's going to be signed as a system app, access to everything, basically. Is it a privileged app? Yes, it will end up in the system/priv app. And then this one is a trickier part here. You need a way for Android to grant all the permissions your app uses instead of the user having to grant them when they start it up the first time. Because let's say you have a device where your app is going to run, it's going to start up and doing stuff before the user even gets a chance to interact with it, or it's a onboarding app, or it does something in the background and you don't really want to display anything to the user. Maybe it even doesn't even have a user interface. So you need a way to tell the system that, okay, grant all these permissions, like from the start. So that's what this file is for. Required here tells us what dependencies on other packages does this package has. So in this case, the required points to an XML file. And the way it points to an XML file, but we're going to see next. But first, we're going to see how does the XML file looks like. It looks like this. You can find these XML files in /system/etc/permission on your device once you've flashed it. And it basically just lists what permissions should be granted from the beginning. Yeah, you provide the package name and then a list of them. And these are basically the ones that you have uses permission for. For this file, you need a separate Android BP, or you can put this. You could also put this pre-built etc statement in the same Android BP you had for the Android app import. Doesn't matter. So you can have multiple statements in one BP file, and then you provide the name for it. And remember, privapp whitelist SE health of my app. That was the same one as that one. So this way, this import statement will go looking for the package that has this name. We say that this is a system extension specific. It should go into the permissions folder. And this is the source, the XML file that we just shown. It should pick up the source from that one. And when you then build build that package which imports the app, it will also generate this file and put it into the system directory. And voila, now you have imported an APK. So basically, you need two files, one blueprint with these build statements, and one XML file for enabling all the permissions. And those the team. Well, and then you need the APK, of course, and then you put this one into your AOSP resource tree or source tree. Now, the third way is a Java SDK library. And why would you need this one? Well, let's say you're building a system app. You all know that there are a bunch of system APIs that are marked as hidden. So they're not part of the official Android SDK that normal Android apps are using. They are but what it means is, even though they are hidden, they're still accessible. So we usually use reflections when we want to do something hacky one-time thing. Many of these, those of you who work with Bluetooth on Android, you know this one. There's a bunch of Bluetooth methods that are hidden that you need to access. And, well, you hack around it by using reflection, basically. That's not very optimal. So another way to get around that for your developers that are doing the apps is to create a Java SDK library that kind of lifts these out. So you don't have to modify the framework. You don't have to hack each developer's local SDK installation, and so on. Now, this is the start of how the blueprint file looks for the Java SDK library. There is a lot more here. And doing the whole full Java SDK library is kind of a little bit outside what I have time for today. It's also documented sparsely on the source Android.com site. You can, if you just search for Java SDK library, it shows up at the first result, and you can read a little bit more there. There are links to some samples, but it also, what it basically includes is first you build your product, and then you build an SDK for that product. And from that SDK, you get an add-on, and that add-on you take, and then each developer links it in their SDK setups. And then you use the uses library XML statement in each manifest for the apps that need that. Okay. So how do you include it? So you have defined your own product, your own packages. Maybe it's a system app, maybe it's an imported app, maybe it's a Java SDK library. Well, all you need to do is in your Android products MK or the one of the other makefiles for that device to just say product packages, append, and you append these three, and then those will be built into that system. And then so the first time you do this, when you've added everything locally, you will see that, oh, it doesn't work, because you need to go in and build each one of these specific before it kind of picks up those changes. It's a little bit, how to say, sensitive about noticing that there is something new in the tree sometimes. So the tip is to go in like this. You go into the packages, apps, my system app, and then you run MMA, which means that you build the package in the current folder. So that's something you need to do once to kind of get it to recognize that everything is there. Okay, that takes me to the end. I have 5 minutes to spare. to see if I have any immediate questions, maybe.
Cool. Thank you, Erik. That was really, really, really good. So somebody must have some questions about any of that.
So let me maybe start about a question, Mathieu here. So just for you to know who is talking, I'm working in the automotive industry in Germany. I'm also a colleague of Santosh, who is also joining and who basically shared this meetup with me. So it's my first one. I have a few questions related to your slide where you're presenting the AOSP My Device at MK. Because
let's go back to that one.
Yes, this is something that bothered me a lot, and I'd never found really some documentation except reading inside the makefile to see exactly what inherit product is doing. So long story short, first of all, it seems that the order in which I use a call inherit product matters.
Oh, yeah, yeah.
I'm not sure about it. And secondly, for me, for example, when I want to test something and I want, let's say, to extend the standard Android emulator, I'm not doing, let's say, complicated My Device MK like this. I'm just call inherit product with the SDK phone x8664. And after that, product name, product device, product brand, product model, and that's it. And everything that I want to add on top, I put some call inherit product before the emulator, the SDK phone MK. Am I doing things in a correct way, or am I doing completely wrong and it just works because I'm lucky?
No, I probably works because you're lucky, but it also sounds correct. Yeah, it is. This is tricky. I don't have any better advice. I probably, like, if I would see the makefile, I could maybe give some hints, but unlikely with this short notice. It's usually when you get to the point that you're going to define your own product, you usually get the source code for the base support package somewhere, and they have a defined like base product for that one, like for that hardware. And usually it's enough to just inherit that one straight off, so you get everything, like, yeah, nothing extra at first, and then you start appending stuff that you need extra. But you said that you're you're working with the SDK, so you're building the emulator.
Yeah, I'm basically building an emulator for playing with it on my local machine, because as I was mentioning in the chat, I tend to, let's say, doubt the stability and correctness of most of the SoC vendor BSPs that they provide, especially the one, if you, I don't want to give brands here, but the small, the small Raspberry Pi like boards that you can buy on Amazon, which are, let's say, running AOSP. If you dig down into it, you see that they're doing some hacky stuff, like, for example, disabling SE Linux and whatsoever. So I don't trust it. So I'm mostly using an emulator, or now I'm starting also to use Cuttlefish. But every time I want to start playing with it, I create my own device subfolder with device MK, and I just put call inherit product, SDK phone, or whatsoever, which is my base.
Can I just jump in here, Mathieu? We're getting towards the end of this slot, so if you can just bring your question to a conclusion.
Yeah, that was it. So I just wanted to know if what I'm doing at the moment is, let's say, correct. Seems to be. I just have one or two remarks based on your slides. Let me check. And Chris, I know I'm taking time. Yes, replacing an app is normally not done over as overlay.
We're going to have to take this afterwards. So there will be time for a Q&A after the next presentation. So so Stefan is going to do his presentation next, and then we have like 30 minutes for general chat, which kind